since technically it's after 3 and 50 minutes is never long enough, let me just go ahead and get a little sense of who you are and why you're here. I've already talked to you, so I know what's going on there. How about you? You brought your team together, right?
Yeah, we're all in the same school.
All right.
I'm Kendall. I teach English actually, but I teach at Sylvan Learning Center, so I'm trying to improve my teaching of math.
I'll make 2 comments with regard to that. My background is mathematics and science. I'm certified in those areas. I have a professional art background, a professional music background, and a linguistics obsession.
Okay then.
I am a language person. You cannot teach anything in any subject area at any level unless language is in command.
Exactly.
Right? And too many math teachers don't understand that. We use all that jargon. 42 minus 17. Can't take 7 from 2, so what do you have to do? You have to borrow from the 4, right? When do you ever pay it back?
You take it.
You just take it.
You take it.
And you see, you don't find that kind of language in the books.
Right.
I actually do a session that I submitted for their approval, but somehow they didn't think it was necessary, called Teaching Mathematics as a Language. There are 5 parts of speech in mathematics. They all behave just like parts of speech in English. With those 5 parts of speech, you can only make 4 kinds of math expressions. In all the universe, there are only 4. Students need to know this. And they've never been told it, nor have we. So, put that down on your evaluation form. We need to have a language session. That's why I gave you this little pamphlet, Spend a Day with the Why Guy. I'm known all over the country as the Why Guy. I will never teach a trick, no rules, no shortcuts, no formulas, never ask kids to memorize anything in a math class. But I'm going to make absolutely certain they know why it works, where it comes from, and why it makes sense to do this. Case in point, how do you divide fractions? You take the second one, you flip it over, we learned that, didn't we? And you multiply, correct? Is that not about the dumbest thing you ever heard in your life? Does it make any sense to a 5th grader when you say we're going to do division? Okay, what do? We make it multiplication. What?
Yeah.
It's okay, just turn the second fraction upside down. You've got to be kidding me. This makes no sense. So we teach students by the time they get into, this is a math session, right? Do you dare to?
Did you just start?
Just start.
Okay. Sure, I'm here. I'm kindergarten. Will I know?
Oh yeah, you'll appreciate the language element of this, I'm sure.
There we go. Thank you.
So a 5th grader says, what are we supposed to do? And you tell them to do that. By the time they get to 6th and 7th grade, they're learning to hate math. Because math makes no sense. The only thing that teacher ever tells me is that she uses the Nike principle of instruction. What's Nike's slogan?
Just
do it. Don't be asking questions in here. Just do what I tell you to do. And the kids are finally saying, I hate this stuff. Now I'm going to make a very broad statement here because I do a lot of staff development. That's what that little brochure is all about. If you'd like to have some staff development time for your teachers, or if you have those professional days, I love that stuff. I like working with elementary teachers. I like working with middle school teachers. Secondary teachers are a little tougher, but I like working with them too. But the fact is, we all need to introspect. We need to think about what we're doing. I don't know if you were at the lunch today, but I'm the guy who spoke up about all the problems we're going to have with staff development when we start doing something new. And I have felt that for years and years and years. Our biggest problem is not the fact that we come up with good things to do, but it's coming up with a staff-developed uniformity in terms of how to use them and the strategies that are necessary and how we have to change our paradigms. So, if you see from this session that that's something that might be helpful to you in your local setting, be delighted to entertain that possibility. So we're talking about the language, and the other thing we were talking about? I'm not sure now. I think maybe I addressed them both. Any other thing you want to add to that, why you're interested in this?
I teach high school math.
High school math.
Yeah.
So story problems are just the bane of every high school math class, right?
Yes, and they do not like them. In the EOC practice that I have, every problem is a word problem. So
And I used to help write SATs.
So you're one of those old guys that sit in a room and talk about this.
And do your best, Mr. Clark. When you write an SAT problem, please try to write a problem that no student has ever seen before. That's the goal.
Yeah.
That's it.
Now that's hardly fair, is it?
That's the goal.
How do you study for SATs? You can't. You have to have this huge ability, this basic knowledge of algebra and geometry, and this huge ability to apply it to a new situation. SAT doesn't stand for Scholastic Achievement Test, a test of what you know. It's Scholastic Aptitude Test. What is your ability to learn? How do you apply what you know to some new situation? And ladies and gentlemen, that's what the scholarship money is given for, because this student is a learner. And very honestly, I teach math, you teach English, you teach art, you teach science. What are we really teaching kids to do? Think, to problem solve. Now, to be honest with you, story problems are sort of a wreck. Everywhere we teach them. Are you sort of in nothing much more to add? I'm just asking, why are you here? You just wondered, right?
Well, I read it in the thing, and like I said, I teach kindergarten. I start at the very bottom.
And you're teaching some story problems, aren't you?
Yeah, we do math journals every day.
So I'm going to fix her right now. At the elementary level, don't ever try to teach story problems.
Okay.
It will not work. You cannot get it done. All you can do at the elementary level is experience story problems.
Okay.
There's your journaling.
Okay.
What did you do? Did we get it right? No. Okay, everybody breathe. Now let's do it again, and do the best you can to expose them as much as possible to problem solving. But there is no formalistic approach to solving everyday problems. There is a formalistic approach that is extremely efficient in solving high school story problems out of a math book, or middle school story problems out of a math book. So that's what we're going to do here in the 45 minutes we have left. All right? I don't know if that introduction covered everything. We don't even have time to ask this gentleman why he's here. We're going to assume he's here for a good reason, and we're going to go on. But when you think about the story problems that we do in school, I have 15 coins in my pocket consisting of nickels and dimes. Remember this stuff?
Oh, no.
Remember this? The total value of the coins is $1.20. How many nickels and dimes do I have in my pocket? Take them out of your pocket and count them, for heaven's sake. Now see, if we're going to teach kids to do problem solving, we need to teach them to do practical problem solving. And you ought to be giving your students extra credit if that's what they wrote on their paper. That student's not looking for some formula. Let me think about this. Take this piece of paper and tell me what gravity is. So these kids start writing. Another kid just simply wads up the piece of paper and drops it on the floor and says, there it is. I mean, the way kids think is sometimes way beyond the way we even consider the possibilities. And we need to be ready to accept that. That's all right. Johnny is half as old as the combined ages of his... Remember this? This is on the last test?
The dime and nickel question, and
I am going to really be interested with great trepidation at your reaction at the end of this time. I write video textbooks. That's my job. That's what I do. I have my own little company, Video Text Interactive. I write video textbooks. I'm the only person in the world that does it. That's also why I asked the question at lunch today about the huge problem of staff development. Flipping the classroom? Why would you even think about flipping the classroom? Especially if you don't have anything to give them at home, right? People have told me now, Mr. Clark, you've been flipping the classroom for the last 15 years and nobody's done it yet. Because my lessons are 5 to 10 minutes long. And they're easily understandable because they're concept development. We've got to think about how we teach children. And we have to change the way we teach children, not because they've changed so much, but because the tools we have give us a lot more opportunities to get inside and help them do conceptual development. So here we go. There are 3 types of problems. There are, in fact, fun problems. That's your department. Because when you do it in kindergarten and you do it at elementary, kids ought to just have fun, thinking critically, doing analysis. By the way, I'm a language freak, right? Look up the word analysis in the dictionary. It doesn't mean think about it. That's what we say analysis is. Analyze, think about it. No, break it down in little bitty pieces. That's what the word analysis means. And that's what these children need to have some experience with at the elementary level. So that's easy. That's a lot of fun. Then there's strategic problem solving. Again, primarily focused at the elementary and middle school, but teaching children strategies on how to solve problems. What are some of the strategies we use at the elementary level to teach kids how to solve problems? You've read this problem. Here's a suggestion. What? Look for the key words. Look for the key words. Now that sort of bugs me as a language person, because when it comes right down to it, every word in the sentence is a key word. If you start leaving out the adjectives, you're in trouble. What do they mean when they say look for the key words? Look for those numerical qualities. Focus in on. We don't really tell them that though, just look for the key words. But that's a strategy, and we ought to explore it. What's another strategy at the elementary level? How about draw a picture? We tell little kids to draw a picture.
Make a
Right?
Make a graph.
Make a graph. There's all kinds of strategies. Take a guess. Oh, I don't like to guess. Might be wrong. You will be wrong. That's the definition of a guess. Okay? A guess is not going to be right, but it's going to be close, and as you get better, it's going to get closer. But at least it gives you a sense. Reasonableness of results, right? That whole idea. So the idea is, in the draw a picture thing, I had 4 cows in this field, 3 cows in this field, and there was a big fence in the middle. One day a big tornado came through it, tore the fence down, and all the cows got together. How many cows do I have all together now? Do you know how long it takes a little kid to draw a cow?
That's the truth.
You might as well get a cappuccino and a little biscotti and relax. Because they got 7 of those things to draw. They don't understand at that level that making a triangle might represent a cow. Right? So at the elementary level, relax. Experience story problems. Enjoy story problems. Celebrate with a popcorn party when you all get one right and cry on each other's shoulders when you get one wrong. But don't think you can teach problem solving to little children. Because until they do what I'm going to do today, they will not have a real sense of the structure and syntax of a story problem. You ready? Now, in the interest of efficiency, I don't want anybody here taking notes. Because if you will email me when this session is over, I will send you a detailed PDF of all the notes in this thing. Okay? We got to get this thing, we got to move, right? And we don't have a lot of time. It's not like a nice staff development session that I might have at a school. We can spend an hour and go over if we have to. We got to get out of here in another 40 minutes. 35 minutes. Okay, so get in touch with me if you need to talk to me about anything. If you want any kind of further information, I'd be glad to entertain the possibility of any kind of problem, of any kind of staff development with you. So at the bottom of the first page, you see it says, so what about textbook problem solving? That's what we want to consider. So on the second and third pages, actually second through fourth pages, you're going to see a fairly detailed analysis, break it down in little bitty pieces, of what we need to do. Now here's my personal philosophy of education. It overrides everything we do in any subject. Our primary responsibility to teach children concepts and how to analyze is to teach them, if I had a little bell, I'd be ringing it right now. When I ring a bell, that's something that's worth taking a note on, I guess. So here's a ding-a-ling. Ready? Our responsibility is to teach students to ask the right questions. Our responsibility is not to say, don't be talking in here. This is math class. You're not supposed to understand anything. Sit down, shut up, do your work. That's not the way we talk to them. We're not going to tell them, just turn that second fraction upside down and multiply. I know it looks dumb, but just do it anyway, because that's what I told you to do. Our job is to teach them to ask the right questions. Case in point, every one of you have experienced this. In math class, teacher's doing problems. You're getting them right. You understand it. Give me one more. Got it. Okay. Take your homework home. Open up the book. Don't even know where to start. Now that happens. Why? Because she was asking all the right questions. And they were intelligent enough to give the right answers. But when they got home, there was nobody there to ask the questions. No matter what we do, whether it's history with cause and effect, whether it's art with composition and center of gravity and perspective, everything we need to do is to teach students to ask the right questions. Make them analysts. Make them discriminating in the way they look at material, the way they absorb it, and how they categorize it. So this session is teaching how to solve story problems in a very structured way, because textbook story problems are not very practical. Anybody would ask you, well, does your math program, and they ask me, does your math program have practical applications? I said, well, sort of, yeah. Sort of. What do you mean, sort of? Well, you got two trains starting at the same station, going in opposite directions, and my approach is, why don't you just get on the train? Quit worrying about how far apart they're going to be after 2 hours. What good does that do you? Now, that's a good math problem, but don't call it a practical application. We have to understand, in the context of education, and specifically in mathematics, what is the purpose and function, and what are the limitations of story problems. Sometimes story problems are just helpful at the elementary level, teaching kids how to read. But as far as solving a problem like that in life, so what you're going to learn today, in the time that's left, is how to ask all the right questions to solve any textbook story problem from middle school up. Ready? And that's good preparation for a teacher at the kindergarten and elementary level, because they need to know what's going to happen to these little guys. And that's part of our problem in staff development. We're so focused in one area, we don't teach them how it impacts on what's coming afterwards. I'm old and cranky now, okay? I'm sorry. I can't help it. I'm opinionated. These kids are smart. Aren't they? Here's your first question. Just go through them with me very quickly, and then I'm going to give you a quick worksheet, and then we're going to just crank out as many as we can. And if you get all excited, we'll just meet somewhere and do the rest of it. Number one, how many things are there in the problem? Now, if you knew something about my language and mathematics presentation, you would know that the things in mathematics behave like the nouns in English. That makes some sense? Things. And the things in a math problem are the things which have value. You notice it says that in the note? These are the main characters. If you're going to write a book report in a math problem, or a math story problem, what's the first question in every book report? Identify the main characters, right? Well, what are you doing in math? You're finding the things. You're identifying the main characters. People can relate to that. And these are the things that have value in the problem. Number two, what are the is sentences? What does that word is make you think of? Oh, I wish we had more time to get into this. Is. When you hear the word is in mathematics, what does that make you think of? Is equal to, is less than, is greater than. That's a relation in mathematics. That's one of the parts of mathematical speech. And it's designed to help you determine the comparisons or the relationships between the things. Here's the kicker. If you've got three things in that problem, you absolutely have to have three is sentences. There is no alternative. Think about it, math people. 1x, all you need is one equation to find it. X and y, what do you need? Two equations. X, y, and z?
3.
You cannot solve any mathematical problem unless you have as many relationships as you have things. Now that's got to make sense to you, but when did anybody ever tell us that? You're just supposed to know it. And we math people can just do it anyway. You don't have to tell us what's going on anyway. And that's a danger to us, because we know it almost innately, inherent to our being. And now we're teaching. Guess what? What's the matter with you? Why can't you do this? What's the matter? Where's your notes? We've done 5 of them. And math teachers are very prone to getting frustrated and taking that attitude because we just did it. But they didn't really know what was going on behind the scenes. Number 3, which is sentence are you going to use for your open sentence? What do you think open means? That's another part of the language expression. When a math expression is open, what does that mean you're going to see in there? It's open. It's not closed. It's open. Open for discussion. Open for input. What are you seeing? X. In. What is in? I don't know. Put something in there for it. It's still open, isn't it? And that's what we call it in mathematics. Anything that has a variable, a placeholder in it, is an open expression. That's very important to understanding this dynamic. One of those is sentences is going to end up being our equation. Pick one. And that's all you have to do. It's not even any harder than that. You pick any one you want. Doesn't matter. That's why the kids struggle whenever we solve the problem on the board easily. They're thinking, how'd they know? I wouldn't have done it that way, and your way may have been just as valid. Very important, especially at the elementary level. Their strategies take you off on little wild goose chases, and you never would have gone there, but all of a sudden, guess what? We see where we're supposed to be. Question number 4. How will you represent the things? Remember your teacher's always saying, let something be X. Remember that? Remember that? Let something be. I got so tired of hearing that. I don't know what to let be X. I just wanted to let the teacher be X. It's frustrating because they don't really know how it all fits together. And finally, number 5, what is the open sentence? Take that open sentence that you saved and translate it now, and you're ready to solve. You ready to go?
Are you ready to go?
Where are they?
I feel like I just got to buckle myself.
I don't want to hear.
We're just what you doing, buddy. Oh, we got, oh. People here. We got
I had more than that.
right
You
here.
can share.
Are those here right now? That's 3 of them. It's 6.
See, you can have a collaborative quality to your classroom. I'm all over the place and I'm always losing stuff, and I depend on the kids to keep track of me. Keep me on track. Here we go. You ready to solve a problem? Did you get one?
Oh, we got them.
All right. All right, we're going to solve a problem. And this will also be in your notes when you get it.
Okay.
All right? Yes.
No, it's 6
Problem
different
solving
ones.
strategy.
No,
Oh,
but I can keep that.
no, that's not. You're going to get that later anyway. That's what you want.
I need one of those. You don't have it, one of them.
Give me 3 different pieces.
Yeah, they should all be the same. I just picked up the wrong stack. That's why I didn't have enough. I need all those back. There we go. Everybody got one? Everybody got one. Are we in business here? All right. All right, look at this simple problem. Now, you can do this problem in your head. We know that. We want to see if we can use it to develop the analytical approach to asking the right questions. The first question is, how many things are there in this problem? Now, think about this as a story. One number is 3 times another number. The sum of the numbers is 24. What are the numbers? Now, what are identify the main characters. How many? 2. Name them for me.
Number and number.
Well, that number's got to be a little fuzzy.
One number.
Okay, let's say one number and another number. She might want to say smaller number and larger number. She didn't speak up quick enough, so now the rest of the class, we're going to go on with this. They need to understand that their choice is as individual as they are. So, we got 2 things. One number, another number, right? What does that mean, students?
2 is sentences.
There have to be 2 is sentences. There have to be 2 statements of relationship between the things. And if you don't understand that language plays a key role here, you need to think again. Can you tell me how these 2 things are related, according to the problem, with the word is in it somewhere?
It's 3 times.
Be specific, but you can be specific. One number is
3 times.
3 times another number. See, if you just say one number is bigger than another, you're saying one number is greater than or equal to. It's not going to get you anywhere. So the problem will allow you to be specific, but do you not have to have a command of language to do this? Because you may have to restate it in your own words. One number is 3 times another number. Right? Do you understand that that's an is sentence? It's a statement of relationship between the things. I tell students, now take your pencil and cross that out. Because if you don't cross that out, you'll find that students try to use the same sentence to say it another way. The another number is 1/3 of the numbers. Oh, that's fine, but that's not a different sentence. It's the same relationship, just stated differently. All right? One number is 3 times another number. Do you have another one?
The sum of numbers is 24.
I don't know what you're talking about. What do you mean, the numbers? When you talk about is sentences and relationships, you have to be specific as to the parties involved.
The sum of one number and another number is 24.
Now, see how her command of language is starting to take over? You can't do this, folks, unless you have really understood the 5 parts of mathematical speech and how they're put together in meaningful expressions with syntax and structure. When students take my algebra course, the first 3 lessons are parts of speech, types of expressions, and translating. You can't even take my algebra course until you have had a language class. And we don't do that. It's just part of the deal. So, sum of, let me make it even more basic. One number plus another number is 24. Is that the sum of the 2 numbers? And students will get very creative about making this very simple and very explicit. Cross that out. Do you have 2 sentences?
Yes.
Yes. You got 2 things. What's the third question? Which is sentence are we going to save for our eventual equation? It's your choice. Which one you want to use?
The first one.
First one. See, some of you say, oh, I want to say. You've got to speak up. You're going to get your classroom participation point. Okay? So somebody wants to save the first one. Okay? Now, what's the next question? How will you represent the things? Right? Now think about the dynamic here. In every case, you have as many is sentences as you have things. And if you save one of those is sentences, you're always going to have one less is sentence than you have things, right? Is everybody clear on that? If you always save one, you're going to have one less is sentence than you have things. Do you now understand why the teacher said, let something be X? You gotta even level the playing field again. Now, how do you decide what to be X? It's up to you, but there are some logical choices. Look at this. One number plus another number is 24. I mean, I'd like to say X and Y. And if you look at pages 3 and 4 of this outline, which we will not have time to do today, you will see the adaptation as to when you have multiple variables. Right now, we're only using one. So we have to do it in a very basic, constructive way. But pages 3 and 4, we'll be able to do it with more than one variable, more than one placeholder. So, one number plus another number is 24. How are you going to represent them? Students, go through this little activity with me, and this is the way we have to model this analysis. I'm thinking of 2 numbers that add up to 30. One of them is 7. What's the other one? Here I come. I'm the Y guy, okay? How'd you get that? You subtracted the known number from the total, right? I'm thinking of 2 numbers that add up to 22. One of them is 14. What's the other one?
Subtract 14 from 22.
Subtract 14 from 22, you get 8, right? You ready? Big finish. Here it comes. Well, I'm throwing it at you really quick. Don't worry about that.
Okay.
I'm thinking of 2 numbers that add up to 24. One of them is X. What's the other one?
24
minus
X.
Subtract the known number from the total. I mean, that's the pattern, right? Are we not supposed to, according to Common Core, are we not supposed to be helping children look for patterns and make generalizations? It ought to be a part of our teaching. Listen, I'm sorry, I got to say this. I know it's going to take a minute. Every 5 to 7 years in this country, the Nationals come up with some new set of standards. It's been happening for 50 years. I've been in this business for almost 50 years. Every 5 to 7 years, here comes another set of standards. Guess what? In mathematics, you're always going to solve a quadratic equation exactly the way you solved it 100 years ago. And 100 years from now, I don't care what the standards are. Now, you know why I'm getting a little excited about Common Core? Because finally, somebody who's dealing with the standards is saying this, and this is right in the overarching statement. Understanding, justification, articulation. What are we now expecting students to do?
Think.
Think and defend. And that's what we should have been doing for years. People have looked at my program and said, Mr. Clark, this has been Common Core before there was Common Core. Because I'm all about the thinking, asking the questions. So if I let one number be x, according to that sentence, since the sum is 24, what's the other one have to be? 24 minus x. That's how you would find it, right? A few examples, a little patterning, look for generalizations. Now the kids can always handle the sum statement because they always know they just let one of them arbitrarily be something and the other one is the total minus that something. We wouldn't have done it this way if you'd have selected the other sentence. And you have to understand that that's a possibility. Or, unfortunately, we don't have time to do this whole problem again, choosing the other sentence. So I'll sort of leave that up to you. Okay, that was step 4. What's step 5?
What is the open sentence?
What is the open sentence? Now, we used that one, didn't we? Open sentence, what do you mean? Oh, you mean the one we saved? Can you now translate that sentence for me using the ways that you represented the things? One number
X.
is equals
Equal
3 times the other number.
3 times 24 minus.
minus 24.
And that's when the kids sort of yawn and say, there's got to be more to it than this. No, there is not. Mathematical problems, story problems, are so completely structured and language-based that really, now here's another ding-a-ling. Ready? Here comes a ding-a-ling. What you're doing when you're teaching kids to solve story problems is, ding-a-ling, teach them how to write a story problem. And what are we doing? Are we not teaching them to write a story problem? Oh, if you've got 3 things, you've got to have 3 sentences. If they know that, then they can break it down. You can't teach a kid to work on a car efficiently unless they've built the car. Every nut and bolt, every piece, put it together. Now they know how to take it apart and solve problems. Does that make some sense? Now I do another whole session called Simplifying Algebra for the Hesitant Learner. They didn't ask for that one either. I mean, I'm sorry, folks. I am very opinionated about this. This is a math session. Everybody knows it, right? This room ought to be packed to standing room only because this is an issue in every school we have across this country. But it's sort of scary to come in here. If I could just think of a way to title it without using the word math in it, I could get them in there. That's another session, how to solve these things. We're not going to do that right now. The solutions will be on your PDF, so you can take a look at that, okay? Does that make some sense? Ask the 5 questions. You have a handle on that? Okay. No more talking amongst yourselves. Here we go. I got to get these in the right order now. And I'm going to skip the first one because it's just another one sort of like that one. But it will be on your notes. How about this one? Find 3 consecutive odd integers such that 4 times the first is 7 less than 3 times the third. Now see, 5 times the third. I can read that in a way to sort of give you a nervous breakdown, can't I? If you just read that to the kids, they'll just go, They flash out on you immediately. Calm down, kids. Let's ask the questions. You ready? Question number 1. What is it? How many things are there in this problem? What are the main characters of this problem? How many are there? Do you notice? 3. And that's just a matter of reading. See, that's what it means by look for the key words. It was more involved than that. How many things? 3. Name them. First, odd. That's important too, isn't it? Science people will have our throats if we don't label things. First odd, second odd, third odd. Does that make sense? Can you see that in the problem? Then you are obligated. What has to happen? There have to be 3 is sentences. Give me one that you know for sure.
One odd number is 4 times the first.
I need to know which one you're talking about, though. See, now you got to talk. You can't just say one of the characters in this. What character? Second. Odd is what?
4 times.
4 times first odd?
Where are you getting this?
I'm not sure.
What does it say? 4 times the first odd
Odd
is
is
7 less
7 less
than 5 times the third odd, right? Now, I'm being very explicit here, and students are going to get tired of this pretty quickly. You're going to say, "I have to write all that stuff." Yes, you do. Until I'm so sure that you know what you're doing that you can start making shortcuts. I don't teach shortcuts. Okay, that's 1. Cross that out. 4 times the first is 7 less than 5 times the third. Okay, we only have to have 2 more is sentences. What do you notice?
There are no
Hey, all my junk's gone, man. I don't have any more junk to work with.
Consecutive.
In consecutive integer problems, always there is what I call an is sentence generator. And all you have to do is flip the switch. What's the first is sentence that's got to come up? Second is 2 more than first. Isn't that true of consecutive odd integers? Well, it didn't say that. No, but it said consecutive odd. Language is a key. You have to understand this language. Okay, it's still, the little generator's still running. What else? Third is 2 more than second. Fourth is turn it off. Because will it not make sentences all day? Fourth is 2 more than the third. Fifth is 2 more than the fourth. Sixth. I don't need all of that. Just turn it on long enough to get the sentences you need. Okay? Do you have 3 sentences now?
Yes.
We're ready. Which is sentence do you want to save for your open sentence? I'm just going to designate, because generally I employ what I call the Scarlet Principle. Anybody know Martin Luther King?
Oh, yes.
Yeah.
What did she always say? What was her catchphrase?
Tomorrow. We'll do it tomorrow.
Yeah, that's right. That's what she said. And then she also said, tomorrow. I'm not going to think about this today, right? Because it's too hard to think about. But I love that. That's right out of the classroom, man.
That was Red Butler.
That's right. That's right.
That was Red.
4 times the first odd is 7 less than 5 times the third. Ooh, what a mess. So let's save that one, just for the sake of discussion. Okay, we still got 3 things, but we only got 2 sentences. Going to have to let one of them be X. Now, we have to do some analysis. We have to say, look at these 2 sentences. What is the foundation piece? What is the piece from which everything else grows? What is the one thing that everything else depends on? Third is 2 more than the second. Second is 2 more than the first. The first one is the one you need. And if you know the first one, you can build, can't you? Does that mean that's the only choice? No, but it's the most logical choice. Tom Clark is the why guy. He will never teach shortcuts, tricks, and rules. He will teach literal, pure mathematics and let kids exercise their insight. Ding-a-ling, you cannot teach insight. So you dare not use it in the classroom. Teach it purely. Teach it in its entirety. So let the first one be X. Then what's the second one?
X plus 2.
Cross it out. What's the third one?
X plus 4.
Well, see, she's already thinking ahead. She hates students like that. X plus 2 plus 2. But Mr. Clark, yeah, I know, good for you. I never would have thought of that. That's what you have to say to them. You have to pretend like you don't know any of those tricks and rules. And you think they'll ever forget that? No way, man, I made that up. All right, you got your things represented. What's the next thing? The last question. What's the is sentence? Oh, you mean that one we saved? Translate it for me. 4 times
first,
which is
times
X
is
Equals
7 less.
7
Beep, 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 beep. You teach them, don't you? With the minus 7 at the end, right? 7 less than 5 times the third,
X plus
2 plus 2.
or X plus 4, as you said. You gave up too easy. There's your equation. Guaranteed to solve the problem. Now you tell me, how in the world can you expect a little child to read that problem and just come up with that equation? They have to have an analysis approach to ask the right questions, something they can depend on. They will start to internalize that, and they'll start doing it faster and faster and faster. Tanika is 8 years older than Sam. 5 times Sam's age 4 years ago is the same as 2 times Tanika's age 6 years from now. Find the ages of Sam and Tanika. You know where the kids are right now? Well, let's see. I wonder what my grade would be if I don't even do that. They can figure out what their grade would be if they leave that one out. They're smart. Ask the questions. How many main characters here? 2. Name them.
Sam and Tanika.
And be careful. Sam and Tanika are not the ones that have a numerical value. It's their ages. See, you got to be really careful about the labels, don't you? All right, you got 2 things. You have 2 is sentences. Talk to me. How are we going to connect Tanika's age and Sam's age?
Tanika's age is 8 years older.
T's age is 8. Mathematically now. More than.
More than.
See the translating that has to go on? 8 more than
Sam.
Sam's age. Good. All right, one more. Here we go. What do you got? 5 times Sam's age.
Minus 4.
Oh, 4 years ago. Oh no. Beep, beep. Hit the pause button. The biggest problem in age problems is the taking you into the past and into the future. If they never take you into the past and the future, they're just plain old number problems. So the beauty, the fascination of age problems is taking you into the past and into the future. So we got to keep track of that, because somewhere along the line, we may need Tanika's age 4 years ago and Sam's age 4 years ago. We may need that. Oh, Mr. Clark, do I have to write all that? Yes. You collect your data. Is this not mathematics? Collect your data, organize it, sort it, classify it. You may not use everything, but you don't know right now what you're going to need. All right. 4 ago. Hit the resume button. Keep going. Is 2 times T's age.
And now you got
6 years from now. Hit the pause button. Hit the pause button. We got to keep track of all these things as they go back and forth in time. 6 from now. Sam's age. 6 from now. Now we still only have 2 things. Everybody understand that? That's what this little dash means. This is 2 things, but we're just taking them back and forth in time. All right? 6 from now. Whew. Which is sentence do you want to save for your open sentence? That was no brainer, isn't it? Let's save that bottom one. That is a mess. What a mess. Now we got to represent the things. Tanika's age and Sam's age. Which one depends on which one? Which one is the one that would be the easiest to start with and find the other one?
Sam.
Where do you always look? Teach students how to analyze this. If you want to know what depends on what, look at the end of the sentence. Because this one is related to that one. That's what the teacher was doing in her head without even knowing she was doing it, and couldn't tell me what to do. Because she'd automatically looked at the end. It was just automatic. Let Sam's age be X. What's Tanika's age? X plus 8. Tom Clark would say 8 plus X. Because Tom Clark is literal. Ding-a-ling, you ready? Don't ever forget that your students, every one of them, are literal. They are literal. They hear what you say. They act on exactly what you say. They are not in the business of knowing what you meant. I'm a parent. I know that very well now. Didn't I tell you? No, you actually didn't. Well, yeah, you knew what I meant. No, Dad, I didn't know what you meant. That's not even what you said. That wasn't even close. They're literal. Don't ever forget that. Oh, before we look any further, though, we're going to have to take them into the past and the future, aren't we? So what's Tanika's age 4 years ago?
X plus 4.
X plus 8 minus 4.
Minus 4.
Good. I'll go with you. What's Sam's age 4 years ago? 4 years ago. X minus 4, right? Be literal. What's Tanika's age 6 years from now?
X plus 8 plus 6.
Right?
Yeah.
And Sam's age 6 from now?
X plus 6.
How in the world do we as teachers expect students to automatically process that without any help in how to analyze it? But we were never taught that, were we? We were just good at it. And people were afraid of us. Because we were math people. We're just weird. We read page numbers for fun. What can I tell you? Okay, so now we've got everything taken care of. I don't know what I'm going to do. Do I have to write all that? I don't know. Let's translate. Ready? Here we go. 5 times Sam's age 4 years ago. Scroll, scroll, scroll.
X minus 4.
X minus 4.
Is 2 times Tanika's age 6 years from now. Scroll, scroll, scroll.
X plus 14.
There's your problem. Guaranteed to solve that story problem. Why? Because you now have the background of knowing how it was built. This agonized me. This was terribly agonizing to me. And you know, we got to be finished. We're about to stop. Let me see here. Where's my other stuff? No, that was numbers. Not going to do that. Oh, I tell you what, just for the sake of the exposure, because we don't, I've got one that's a geometric figure problem, you know? Make a face like that. But let's just at least start to set up the motion problem. Remember those? A car leaves Sioux City.
Oh my God.
Traveling west at a constant speed of 60. 2 hours later, another car leaves Sioux City, traveling the same direction, constant speed of 75. How long will it take for the faster car to catch the slower one? I don't have the foggiest idea. But I can now stop, because I have a battery of analysis questions I can ask. When you look at a motion problem, how many things are in the problem? We're looking for things that have value. Have a numerical value attached to them. I know, see, you got me where you want me because you know I got to stop, so I have to tell you.
You got 2 cars.
You got 2 cars, and each one of those cars operates under the universal law of motion, which says distance is rate times time. So in a motion problem, you always have 6 things. Distance of the slower car, rate of the slower car, time of the slower car. Distance of the faster car, rate of the faster car, time of the faster car. No wonder this is what motion, this is the definition of motion sickness. Okay? That's what this is. The point is there are 6 things and those kids are already groaning. Why?
They want to write 6 sentences.
They got to write 6 sentences. Now you have to be careful about this. Let's just sort of extrapolate. Let's focus. Look at this problem and tell me the distances. Does it specifically tell you the distances? No. Then it must tell me a relationship between the distances. Can you tell? What in the problem tells you the relationship between the distances that the 2 cars travel?
60 kilometers per hour.
They're what? No, that's time.
That's
Not
time.
interested in direction. Not interested in direction.
60 kilometers per hour.
That's a rate of speed.
Oh, Jesus.
I just want how far did they go?
How far they went? Well, one of them went
If
120
he's traveling
miles.
60 miles per hour and he goes 2 hours.
That's 120,
No, I don't know. I mean the total distance. Here's the word, folks.
120, 60 times 2 hours.
What's the distance of the first car? I don't know. What's the distance of the second car? I don't know. But I know it's exactly the same as the distance of the first car because the second car caught it. Didn't it?
Yes.
Distance of the slow is distance of the fast. That has to be the case. Catch. Overtake. See what you teach when you teach language and math? You teach all those words that can translate so that kids have a battery of results. Okay, we're over time. Rates. Talk to me about rates. Does it specifically tell you the rates? Yes, then let's write those down. Those are great is sentences. Rate of the slow is.
60 miles an hour.
Rate of the fast is.
75.
Oh, that's cool. We got 2 more sentences. We only got 3 to go. Let's talk about the time. The time that they were traveling. How does the slow time compare to the fast time? Be careful. It's not on the. You don't look at the clock. You have to look at the problem. How does the slow time compare to the fast time?
Is it X and then X?
But which is which? That's the key.
Okay. Slower times X.
Well, don't translate yet. Just talk to me.
Oh.
The slower time compares how to the faster time?
It's
2 hours.
2 hours later.
More.
More. It's 2
2
hours
hours
more
more.
than, because it left 2 hours earlier. So it's time of traveling. See, this is not something you teach at the high school. I'm telling you, ding-a-ling, I can fix this country in math. If you'll give me the middle school people. Because the middle school people are responsible to take elementary concepts and reteach them so that they can be applied algebraically. And we don't do that in this country. In middle school, all we do is review the arithmetic and then plop them down in an algebra class and wonder why they're having trouble. I'm old and cranky. Time of the slow is 2 more than time of the fast. That means you've taken care of distance, rate, and time, right? And you have 2 empty spaces, don't you? You will always have 2 empty spaces. Always in a motion problem. There are 2 inherent is sentences that belong in every motion problem. Guaranteed, never to be left out. You ready? Distance of the first is rate of the first times time of the first. Distance of the second, or slower, is rate of the slower times time of the slower. And heaven help us if it's a boat in a river with a current. Because that means there are 7 things, and I'm guaranteeing you there's going to be another is sentence in there. But you see, even as tough as that is, don't you think students would take some solace, some comfort in the fact that I may not be able to solve it, but I know the questions to ask now. And look, folks, my biggest goal in teaching story problems to kids in school is to change their attitudes. Look how smart you are. We don't have time to do anymore. We need an hour at least on this. And I will send you the whole packet so you can take a look at it, but you're welcome to give me a call back if you want to get in touch with me, whether it's in staff development efforts for your staff or whether it's just to ask me more questions about how to solve these crazy story problems. I'll be glad to talk to you about it. Thank you so much for coming.
Thank you.
Appreciate it.